In the previous episodes, we explored the maintenance tsunami facing modern buildings and the deeper cause behind it, fragmentation. But fragmentation doesn't just make systems harder to maintain. It also affects something even more fundamental: quality. In the past, lighting systems were built on stable, standardized platforms. Fluorescent lamps, ballasts, and fixtures were produced at massive scale, millions of identical units. This scale enabled something critical: consistency. When products are manufactured in large volumes, materials are controlled, processes are optimized, and performance is tested repeatedly. Over time, systems become predictable, reliable. Fragmentation breaks that model. Instead of a few standardized platforms, the industry now produces thousands of customized designs. Different drivers, different LED boards, different thermal structures, different mechanical layouts. Each product becomes a small batch, and small batches introduce variability. Variability in materials, variability in assembly, variability in performance. From an engineering perspective, this is a fundamental shift. In a fragmented system, quality is no longer defined by design alone. It becomes dependent on execution. Let's look at one example: driver electronics. LED drivers are responsible for converting high-voltage AC power into controlled current for the LED. This is a complex power conversion process. It involves power semiconductor devices, transformer, capacitors, thermal management, and protection circuits. In a standardized system, driver designs are refined over many product generations. Weak points are identified. Failure modes are understood. Design margins are improved. But in a fragmented market, many drivers are designed once, produced in limited quantities, and never fully validated in long-term field conditions. As a result, the weakest component often defines the system's lifetime. And in many LED fixtures, that weakest component is the driver. Another critical factor is thermal design. LED systems generate heat. Not as much as traditional lighting, but still enough to affect electronics. In integrated luminaires, the LED board, driver, and enclosure are tightly packed together. Heat accumulates inside the fixture. And because each design is unique, thermal performance varies widely. Some products perform well, others degrade much faster than expected. This leads to a common real-world pattern. Two fixtures installed side by side with the same specification on paper can have completely different lifetimes. From the outside, they look identical. But internally, they are not the same system. Fragmentation also affects supply chains. In a standardized system, components are interchangeable. Multiple suppliers can provide compatible parts. In a fragmented system, each product depends on a specific combination of components. If one component changes or becomes unavailable, the entire product may need to be redesigned. This reduces the ability to maintain quality over time, because consistency requires stability in the supply chain. There is also a testing challenge. When every product is different, it becomes difficult to perform meaningful long-term validation. Instead of testing one platform deeply, the industry tests many products shallowly. And shallow testing cannot reveal long-term failure modes. This is why many issues only appear after installation, months later or years later. Flicker, driver failure, color shift, popcorn failure. These are not random defects. They are symptoms of a fragmented system. The key point is this: quality is not just about meeting specifications on paper. It is about long-term consistency in real-world conditions. And consistency requires standardization, scale, and repetition. When those conditions disappear, quality becomes unpredictable.